In this video, we're going to talk about utility maximization. And this goes to the heart of the basic idea of economics. People have unlimited wants, but limited resources. So what we want to talk about is the theory behind how is it, what are the kinds of processes that might go through someone's brain whenever they maximize their utility. Now, the theory we're going to be talking about is not actually the mechanics, it's not actually the calculations that we think the human brain does go through, but it does help us predict how people act. And so when we test this theory, it seems to work, and that helps us make predictions and kind of understand some of the underlying processes of people's behavior when they're rationally maximizing their utility. So how do people use their money, their limited resource of money, or other things like time, in order to maximize their happiness? Well, the idea of utility is basically that as we consume more stuff, we get more utility. And utility is just what we call happiness or satisfaction. Key assumption about human behavior that usually we see is that as we consume more of the same stuff, like we're eating additional slices of pizza or we're drinking more bottles of water, each additional unit gives us a little less additional utility or a little less marginal utility, right? That key word in economics coming back, marginal. So what we see is the first thing you consume, like the first bite of pizza or the first sip of water when you're thirsty, is going to make you a lot happier. But the second bite of pizza or the second sip of water will make you happier, sure, but a little less happy, a little less additional satisfaction than the first one. And so we call this idea the law of diminishing marginal utility. It doesn't mean that your happiness goes down, but the additional happiness you get is a little less and a little less and a little less. So we could eventually get zero additional utility from, say, a 10th bottle of water. After the 9th bottle of water, well, the 9th one might make me happier. The 10th one, I could take it or leave it. So we'd say that the marginal utility of the 10th bottle of water is zero, mu equals zero. Sometimes we'll call that kind of idea a saturation point. I'm just saturated with water. I don't really want any more, and any more isn't going to make me happier. So in addition to the idea that, well, we might consume something and get no additional utility, we could actually overdo it. Have you ever accidentally eaten too much and then kind of regretted it? Well, that's what we would call negative marginal utility or negative additional utility. So it might be that you ate a 9th slice of pizza and you were okay eating that. It made you a little bit happier. But then you go too far and you eat that 10th slice of pizza and it makes you actually feel worse. Now, usually we're going to assume that people won't do that, but mistakes do happen. So all those things can fit into this framework of talking about total utility. How much total happiness do you have from doing something? And marginal utility. How much additional happiness do you get from each additional unit of doing something? So there might be some exceptions to the law of diminishing marginal utility. Again, the law of diminishing marginal utility assumes that most of the time you're going to feel that each additional unit adds to your happiness just a little bit less than the previous one. So as you watch more movies, yeah, you get happier. But the second movie and the third and the fourth movie will make you a little less additional happy than the first one did. So we start to tire of things a little bit as we consume more of them. But one exception might be maybe drugs, maybe in their reaction in the brain by causing people to become addicted. Maybe this is one reason that explains how people become addicted to drugs. We assume that people are rational. People try to weigh the costs and the benefits of doing things and try to make purposeful choices that make them better off. Well, if that's true, how do people get addicted to drugs? It could be that some factor of the drug interacting with the body and the brain makes people believe that the second one is better than the first one. I've talked to some people who are drinking too much, and sometimes they have this perception that the second beer tastes better than the first. And the fourth one tastes even better than the second one. And once they really get going, that eighth or ninth one is really, really good. They think it's adding to their enjoyment more than the first one did. To an objective observer, maybe we think they're wrong about that. And after the experience the next day, they might agree with you that maybe they shouldn't have done that so much, right? Let's get into the theory of utility maximization and how it might work. And first today, in this video, we're going to talk about the Berkey method of understanding this. In order to do this, we need to talk about budget lines. Now, I have a previous video on budget lines, so I'm not going to go through this as slowly as I have before. I'll leave a link to that video so that you can find it. But basically, the theory here is we want to balance what we want to have with what we can afford. The theory takes your utility, how much you enjoy things, and your money that you have, your budget, and how much things cost, and we try to intersect those two things. What would you like to have versus what can you have, and then try to figure out how it is that we can pick the combination of things to spend your money on that makes you as happy as possible. So the first step is to try to understand the things you can actually afford, and that's what budget lines are good at doing. If you go way back and think about production possibilities frontiers, that's a line or a curve showing the maximum amount of various combinations of goods that can be produced, say in a country or by a person. A budget line we can think about as being a consumption possibilities frontier, where it shows us the maximum combinations of goods that can be purchased with your income. A couple of different ways you can think about a budget line. Number one, let's graph it. And to graph it, the easiest way is to just ask yourself two questions. So if we have two goods, X and Y, if I bought 0X, how many Ys could I buy? So we're going to graph it on a grid like this, where we have the amount of good X on the X-axis, the amount of good Y on the Y-axis, and let's just graph an example here so we can see how this works. So suppose we had a budget of $200, and the price of good X was $10, and the price of good Y was $20. We want to ask ourselves these two questions. First, if I had $200 and I wanted to spend all my money on good Y, so that's this first question here. If we bought no X's, how many Y's could we buy? The calculation we want to do is to take our budget, that $200, and divide it by the price of good Y, which we said here was $20. So if you have $200 and each Y that you might buy would cost $20 a piece, that tells you that you could afford 10 Ys if you spent all your money, if you spent all 200 on those. So let's graph that point. So that point is going to be right down here where we're looking at 0 X's. We could afford 10 Y's. So that's that point. Now we need to find the other point, which is just asking the question, how many X's could we afford if we bought 0 Y's? So we do a similar kind of calculation. We take our $200 that we have in our budget and we divide it by the price of each X, and each X is $10, and that tells us that we could afford 20 X's if we spent all of our $200 on the X's. All right, so let's put that point down here. 0 Y's, we could buy 20 X's, and now we want to connect those points with a straight line. And here's our first budget line. We have $200, the price of Y is 20, the price of X is 10, and we have our budget line. And again, what this shows us is all the different ways we could spend $200 in this scenario. So this point right here in the middle says that one of the possibilities we could afford would be 8 X's. 8 X's are going to be $80. Plus, we could also afford 6 Y's if we're only buying 8 X's. 6 Y's will be 6 times 20 or $120. So this is another way to spend our $200. Every point along this line is a different way we could spend the money. Now, one thing we always want to think about with a budget line is what's the slope. So the slope of this line between the two end points, we're going down 10 and over 20. That's minus 10 over 20, and so the slope is minus 1/2. And that tells us that whenever we want to get more x, how many y's do we have to give up to get one more x? Well, if we zoom in here, we can see that as we go over 1, we have to go down a half. Over 1, down a half. Over 1, down a half. And that just comes from the fact that y's cost $20, twice as much as an x. And so if I want one more x, I would only have to give up a half of one of my y's to get the $10 that it's going to cost, right? Okay, let's graph a couple more budget lines to make sure we have the idea here real quickly. Suppose that our budget was cut to $150. Now we're just going to do exactly the same calculations, except we're going to take our $150 and we're going to divide that by 20, and we're going to get 7.5. And that's how many y's we could afford if we spent all $150 on y's. And 150 divided by 10 says we could buy 15 x's if we spent all of that money on x's. Let's graph those points and graph the line that connects them. So the first point is 0 x's and 7.5 y's. If we bought 0 y's, we could afford 15 x's. And we connect those 2 points. So what do we see about this line? What happened to the slope? Well, the slope is exactly the same, right? The slope is the same because the orange line is parallel to the green line. The slope is still minus 1/2 because what that represents is that opportunity cost. When you want to get one more x, you have to give up half of a y. One more x, give up half of a y, right? Same slope, but it's shifted in parallel, which means we have less consumption possibilities now. Okay, let's graph one more budget line here. What would happen if now we have $150, but we decrease the price of y to $10? All right, well now we're going to take our $150. We're going to divide it by the price of y, which is now 10. And that says that we could afford 15 y's, twice as many. And we take our $150 and we divide it by $10, which is still the price of x, and we could afford 15 x's. Let's label those 2 points down here, connect them. So our 2 points are 0 x's, 15 y's, 0 y's, 15 x's. Connect those 2 dots. And now we have this purple budget line. What's the slope of the purple line? Well, it's minus 1, because between the 2 endpoints we're going down 15 and over 15. Minus 15 over 15, rise over run, gives us a slope of minus 1. And that minus 1 is the opportunity cost. Again, it tells us that if we start at any point and we want more x's, we have to give up one y to get each x. Because they're the same price, we can trade them 1 for 1 now. And when we zoom out, we can also see that our consumption possibilities have improved here compared to the orange line. There are a lot of combinations we can afford now that we could not afford before the price went down. So in some ways, when the price goes down, it makes you feel like you have more money, right? It's not exactly the same. Okay, let's use this knowledge about budget lines to talk about how do we maximize utility the Berkey way. So again, make sure that you have downloaded and printed out this handout so that you can do this along with us. Do it together here. So here what we have is a total utility table. We have a grid where we have analyzed a person and come up with the amount of utility this person gets for various combinations of 2 goods, pretzels on the x-axis and beers on the y-axis. So just to pick one of these numbers at random here, this one, that 100 tells us this person gets 100 happiness, 100 utils of happiness when this person eats 2 pretzels and has 3 beers. Another point we might want to look at here is this 0. And this is saying that this person gets no happiness from beer and pretzels when they have no pretzels and they have no beer, right? Basically, all we're looking for is a higher number tells us this person is happier. So this is a total utility table. In the next video, we'll do this the way the textbook wants us to do it. There are a lot of interesting insights you can get by doing it that way that you can't get by doing it the simple Berkey way. But we're going to do it the Berkey way first because we can kind of get a feel for how this works better, I believe. So what we want to do is use this total utility table And we're going to go through a bunch of different scenarios that are listed down here. 5 different scenarios where we have different budgets and different prices. And what we want to do is draw our budget lines like we were doing before and see what happens. Scenario 1, budget is $10. The price of beer is $2. The price of pretzels are also $2. Now what's this budget line going to look like? Let's find the 2 extreme ends of what a budget line would be. If we spend all $10 on beer, we could buy 5, right? $10 divided by $2 means we could buy 5 of them. And the same thing with pretzels. $10 divided by $2, we could afford 5 pretzels if we spent all of our money on pretzels. And if we connect all the points in between, we'll see what the budget line looks like. Okay, well let's go up here and let's do that. So I'm going to choose my yellow highlighter here. And here's one extreme point is we could buy 5 beers and no pretzels, and that would make this person 80 happy. At the other extreme, 0 beer and 5 pretzels, well, that would make this person only 51 happy. But we can afford all these possibilities in between. So how do we maximize this person's utility? Well, pick the biggest number, right? Which combination along that yellow line gives this person the most happiness? Right, it's this one where the person has 2 pretzels and 3 beers and they are 100 happy. That's the great thing about the simple Berkey method is we get our answers pretty quickly. So let's write down that solution. 2 pretzels, 3 beers, 100 happiness. So 2 pretzels, 3 beers, total utility equals 100. All right, scenario 2, pure income effect. Pure income effect is just a fancy way of saying, let's give this person more money, but let's not change the prices. So we're just giving this person $12 now, and we're keeping the price of beer $2 and the price of pretzels $2. So what's the budget line going to look like now? Well, if we spend $12 on beer, we could afford 6. If we spend $12 on pretzels, we could afford 6. So let's go up and draw our new budget line. So here's one extreme point, 0 pretzels and 6 beers. Here's another extreme point, 6 pretzels and 0 beers. And we'll connect all those possibilities in between. Now notice how the budget line in both of these have a slope of -1. That's the opportunity cost. If you want another pretzel, you have to give up a beer. Want another pretzel, you have to give up a beer because they're the same price. So what would this person pick if they were to pick which combination of pretzels and beers is going to make them the happiest? Well, we have 2 options here that would give this person 110 happiness, right there and right there. So it could be either 3 pretzels and 3 beers or 2 pretzels and 4 beers. So it looks like for this particular individual, they could either spend that extra $2 on another pretzel or another beer, and it would give them 10 more happiness, 10 marginal utility, right? And this person is kind of indifferent as to which of those 2 they do. So let's write down those 2 solutions. So 3 pretzels, 3 beer, or 2 pretzels, 4 beer for a total utility of 110. All right, now let's see how this person reacts if we start changing some prices. Let's go back to our budget of $10. Price of beer is $2, but now we're having a sale on pretzels. Pretzels are only $1. All right, so what is this budget line going to look like? Well, if we spend all of our money on beer, we could afford 5. If we spend all of our money on pretzels, we could afford 10. $10 divided by $1. Okay, let's draw this budget line. So let me use green for this budget line. So here's one of the things we could afford here. Now, if we go to the other end, or if we try to go to the other end down here, we don't have 10 pretzels on this graph. Are we stuck? No. We can use the idea of the slope to help us out here. So let's see what other kinds of points we could afford. Suppose this person gave up one of their beers, and we went from 5 down to 4 beer. How many pretzels could the person now afford with the $2 they have left? Well, they could afford 2 pretzels, right? Because each pretzel only costs $1. Go down 1 beer, we go over 2 pretzels. So another combination they could afford here would be 4 beers, 2 pretzels. And we could do the same thing. We could go down another beer to 3, and we could afford 2 more pretzels. All right here. Now if we went down 1, we could go over 2. So the slope here is going to be down 1 over 2, or minus 1/2, because that's telling us that for each beer we give up, we can afford 2 pretzels, because beers are twice as expensive. Okay, so let's connect these points here, and it looks like there's only 4 possibilities this person can afford. Which one maximizes their utility? Well, it's going to be this one right here, the 115 total happiness, total utils, 4 pretzels and 3 beers. All right, let's write down this solution. So if we look at the 3 outcomes so far, it looks like this one, where we're having a sale on pretzels, is the one that makes this person happiest. This kind of teaches us a lesson, right? That it's not necessarily as important how much money you have, 10 versus 12. It's what you can actually buy with the money that is just as important, if not more important, right? So this person's more happy having a sale on pretzels than they would be with $2 more. All right, scenario 4. Suppose we have a budget of $10. Price of beer is $2, and pretzels are now free. So we went to a place where they just have pretzels in bowls laying on the counter there, and you can just take as many as you like. What's this budget line going to look like? Well, we could still afford 5 beers, right? How many pretzels could we afford? Any amount we wanted to, right? Let's do this one in red. So here's one thing we could afford, and basically we could afford anything on this row. We don't have to give up any beers at all in order to get more pretzels, so our budget line is just a horizontal line here. Out of all these red possibilities, which one are we going to predict this person would pick? Well, it's going to be one of these 2 over here on the right. It's either going to be 5 pretzels and 5 beers, or 6 pretzels and 5 beers. Impossible to tell. The person is indifferent between those 2 outcomes. They both give 131 utils in total happiness. I'm just going to pick one of these 2. I'll pick this one, 5 pretzels and 5 beers, although if the pretzels were just sitting there and it didn't cost anything at all and not even any effort, then this person might eat the 6th one, even though it's not going to really make them any happier. Let's just pick 5 beers and 5 pretzels as our prediction. All right, that takes us to scenario number 5. Our budget is $20, price of beer is $4, and the price of pretzels are $4. I want you to think about this one. What would the budget line look like, and what would the person's choice be that maximizes their utility? Take a second and think about that. Well, how many beers could they afford? 5. How many pretzels could they afford? 5, if they spent all their money on pretzels. So that is going to be the exact same as that yellow budget line that we drew in number 1. And if the budget line is the same, the prediction for what the person's going to choose must also be the same. 2 pretzels and 3 beers. The outcome here is going to be exactly the same as number 1. The only thing we did is we doubled the prices, but we also gave the person twice as much money. There's a lesson here as well that makes sense in real life. What I think about in this case is maybe you move to a city where you're going to make more money, but everything costs more too. And so if everything costs more and you're making more money, maybe you're not going to be happier there after all, if you can't afford to buy any more things with the money that you're getting, right? Okay, so that brings us to the last thing we can do. Let's wrap up this whole scenario in a bow and see what can we really learn from this. Well, we can see where demand comes from. Remember what a demand curve tells us. It tells us how, as the price changes, ceteris paribus, the quantity demanded changes. So what we can do is we can use scenarios 1, 3, and 4 here to make a demand curve. We want to hold constant tastes and preferences. Okay, that's the table we were looking at. And income. And we want to keep the prices of related goods constant. So in numbers 1, 3, and 4, we all have $10 and the price of beer is always $2. But what we're changing is the price of pretzels from $2 to $1 to $0 or free. So what that lets us do is see the quantity demanded and how it changes as the price changes. We observe three prices for pretzels: $2, $1, and 0. And then we observe that ceteris paribus, at a price of $2, the person wants 2 pretzels. All right, so 1, 2. There's 1 point on our demand curve. When we lower the price to $1, the person now wants to buy 4 pretzels. So $1, 4 pretzels, there's another point. And then when we lower the price to free, the person wants 5 pretzels. If we connect these 3 points together, we get a demand curve for pretzels. As prices change, how does the quantity demanded change? Now we can also look at scenario number 2, and we can see how a demand curve shifts when we give somebody a different amount of income to spend. So in number 2, we changed the budget. We gave them $12, price of beer was 2, price of pretzels was 2, so all we did was, ceteris paribus, give the person more income. And so we see at this same price of $2, when we give them more income, they want to buy, well, let's pick this one. Just to make it easy, let's assume they picked this one where they get 3 pretzels. That way we can see this shift in demand. At a price of $2, now they're going to buy 3 pretzels, right? And we see that this point here must be on a different demand curve. Now, we haven't done enough analysis to see exactly where this demand curve would be, but it's going to be somewhere to the right, right? And this would be our new demand after we get more money. We see that shift. Something changed about this consumer that makes them want to buy more at each price compared to what they used to, and that change was an increase in their income. All right, one last thing I'm going to talk about here, and that's briefly about the diamond and water paradox. And then we'll come back in our next video and we'll see how the marginal utility per dollar method works that the textbooks like us to use. So usually in a chapter like this, we want to talk about the diamond water paradox. Adam Smith talked about this, and not just Adam Smith, but many philosophers before him had thought about this paradox. The idea being that diamonds cost a lot of money, but you can live without them. Water, you'll die without it, but it's usually pretty cheap. So let's see what Adam Smith had to say in his book, The Wealth of Nations, about this. He says, "What are the rules which men naturally observe in exchanging them," he means goods, "for money or for one another, I shall now proceed to examine." This is how he usually talks in his book. I shall now proceed to examine. "These rules determine what may be called the relative or exchangeable value of goods." The word value, it is to be observed, has 2 different meanings. Sometimes expresses the utility of some particular object, and sometimes the power of purchasing other goods, which the possession of that object conveys. So he's saying one way is like how happy it makes you, how much usefulness, although we don't like to use the word usefulness anymore, how much happiness you get out of something, versus like the market value of something. So one may be called the value in use, the happiness value, the other the value in exchange. The things which have the greatest value in use frequently have little or no value in exchange. On the contrary, those which have the greatest value in exchange frequently have little or no use value. Nothing is more useful than water, but it will purchase scarcely anything. Scarcely anything can be had in exchange for it. A diamond, on the contrary, has scarcely any use value, but a great quantity of other goods may frequently be had in exchange for it. So philosophers wrestled with this idea for many centuries. What is the source of the value of things? And what Adam Smith here is trying to say, well, you have to really clarify what you mean when you say the word value. Is it market value, the price of it, or is it how much happiness it can give you? So this diamond water paradox can be solved really by looking at the supply. Let's suppose that the demand for diamonds and for water are actually identical. They're probably not, but let's just suppose for the sake of argument that they were. Why is the price of diamonds so high? Well, because the supply of diamonds is very low. So that's going to cause the price to be a high price, maybe $1,000 for a medium quality half-carat diamond, for example, right? And because we don't buy a lot of diamonds, the additional utility you'll get from another diamond is probably going to be high because you don't have them laying around, right? That diminishing utility hasn't kicked in quite as much if you only have 2 or 3 diamonds. For water, the supply of water is very high. So since water is more plentiful, the market price is going to be a lot lower. And because we're going to consume a lot more water than we are diamonds, the marginal utility that we get for water, for the last bit of water we use, is not going to be very high. But the total utility, the total happiness or satisfaction that water gives us is going to be a lot bigger than the total happiness or satisfaction we get from the diamonds that we usually have. So I'm going to end this video here. Please join me for the next video where we analyze the same problems here using a more textbook standard method. We're going to come up with the same answers, but by doing it the way the textbook wants us to do it, by calculating the marginal utility and the marginal utility per dollar, there are a few important lessons we're going to be able to get. And this is an important analysis tool that we're going to want to have. Please join me for that video. I'll see you next time.